In a discrete time system, a digital signal processor samples a symmetric signal S of n at time instants which are separated by equal time intervals. The signal is once more even. The samples are taken as n being the same as negative k to n being the same as k. The designer is concerned with computing the total sum using non-negative samples only so that the processing can be simplified, and then that the amount of memory can be minimized. So here we're meant to demonstrate that the total of the signal samples or sequence of the full range satisfies the given formulation, which is sigma, for which n takes on limit from negative k to k s of n being the same as s of naught, plus twice sigma n being the same as 1 to k s of n. So here we want to assume that the standard definition of an even signal subsists. So this question is more like the question solved in Q9, only that this is in the discrete sense. So we just bring it in, and then we solve this. So we can as well say sigma, which is the same as negative k to k s of n is the same sigma and the same as negative k to negative 1 s of n plus s of naught. So meaning the sequence, the samples in the sequence from negative k to negative 1. Then we have at point 0. Then so the samples at n equal to 1 from 1 to k s of n. So if we assume that n is the same as negative n in the first term, on the right-hand side, we have, as for this thing, we have that sigma, which the samples are taken from negative k to negative 1 s of n is the same sigma, which n is equal to 1 to k s of n. Okay. It's already assumed n to be the same as negative n. And now we already know that s of n is even, so that s of minus m will be the same as s of m. Hence, we have sigma n equal to 1 to k s minus m will be the same sigma n equal to 1 to k s of m being the same as sigma n equal to 1 to k s of n. Therefore, sigma equal to negative k to k s of n is the same as sigma n equal to 1 k s of n plus s of naught plus sigma n equal to 1 to k s of n. So that sigma n equal to negative k to k s of n is the same as s of, we have s of naught, this and this are the same, so that would be s of naught plus twice sigma n equal to 1 to k s of n, which is expected.